Hi, my name is Jim Cook. I'm one of the instructors for elearntosail.com, and this module is titled Latitude, Longitude, and the Nautical Mile. Now, we use this module as an advertisement as well, so if you are not a student, you will not have a copy of the charts that we're using, but it is a chart that we hand out when you do become a student. I think you'll be able to follow along. The principles are fairly straightforward. So the first thing we're going to do is talk about some definitions. And some of this may seem fairly simplistic to some of you, but I'd like to cover it just the same because there are certain points that I want to make sure get covered. The first definition is, what is a circle? And you can see right here we have a circle. A circle is a set of points forming a line in a plane that are all a given distance from a given point, that being the center. There's a couple of things that we want to make sure we talk about with a circle. The first point is that, especially in navigation, we measure circles through 360 degrees. In other words, if you start from a starting point, and I'll just pick this spot right here, the circle gets measured in 360 degrees in either a clockwise or a counterclockwise direction. So if this is our starting point, we measure 0, we go through 360 degrees. The 360 degree mark is the same as the 0 degree mark. So if you've got something like 450 degrees, that is 360 degrees plus a 90 degree, so you've gone 1 1/4 times around the circle. Now, in navigation, we typically start from 0 being straight up and measure 0 through 360 degrees in a clockwise direction. East is 90 degrees, south is 180 degrees, west is 270 degrees. Those are our typical measurements. The next point I want to discuss is about each individual degree. So starting from here, we measure 360 degrees in a clockwise direction. Degree number 1 is somewhere in this neighborhood. Now, I haven't been able to draw it accurately, obviously, because I don't have a big enough circle. But this represents 1 degree. Each degree is divided into 60 minutes, and each minute is divided into 60 seconds. So in 1 degree, there are 3,600 individual segments. So there are 60 seconds within a minute and 60 minutes within a degree. So 60 times 60 is equal to 3,600. So each degree contains 3,600 increments. Now, on a circle this small, we're not going to be able to see that. But when we deal with a circle the size of the Earth that has a very large circumference, then we can make out the difference between each individual second and each individual minute. Let's talk about the Earth. What is a globe? A globe is a 3-dimensional circle. So in other words, if you take a circle and spin it around on its axis, you will create a globe. And the most common globe we know of is our Earth. Now, on the Earth, we have a grid pattern that has been set up. And this grid pattern is described in terms of latitude and longitude. So let's talk about latitude first. So you can see here we have different lines of latitude. This is the equator, and then this would be a line of latitude to the north, and this would be a line of latitude to the south. Which line of latitude? Well, if we look at it from the equator to the North Pole is 90 degrees. So if we go 1, 2, 3, 4, 5, and 6 would be the North Pole. We divide 90 by 6, and we get each one of these would be equal to 15 degrees, and you can see it right here. But it's important to realize that each of these degrees of latitude represent an angle from the center of the Earth up to that 15 degree mark, or the 30 degree mark, or 45, whatever it happens to be. So this area in here would be divided into 15 degrees. Each one of those degrees would be divided into 60 minutes, and each one of those minutes would be divided into 60 seconds. The equator is a latitude line that bisects the Earth. So that's the only one that bisects the Earth. And latitude lines are measured from 0 degrees at the equator, north 90 degrees, and south 90 degrees. So how do we get a full 360-degree circle? We measure 0 to 90 at the South Pole, another 90 back up to the equator, 90 again to the North Pole, and 90 back down to the equator. So that gives us 4 segments of 90 degrees, 360 degrees. Now the vertical lines of that grid are called longitude. Lines of longitude are different than lines of latitude in that they start at the North Pole and go all the way down to the South Pole. The starting point, or the 0 degree point, is called the prime meridian, and it goes through Greenwich, England. The lines of longitude are then measured 0 through 180 degrees in a westerly direction and 0 through 180 degrees in an easterly direction. So at the back of the globe, as we're looking at it, there is a 180 degree line. As with the lines of latitude, it's important to realize that each one of these lines of longitude is a measurement from the center of the Earth coming out to the crust of the Earth, and each one of these degrees is an actual measurement from the center of the Earth. This diagram to our left is showing that, as with latitude, it's important to realize that each one of these lines of longitude is a measurement from the center of the Earth. So going back over to our diagram on the right, here is the center of the Earth. Here is our 0 degree line. Coming out here is 15 degrees. So as with the latitude, this segment represents 15 degrees. So there would be 15 degrees of arc. Within each of those degrees of arc, there would be 60 minutes of arc. And within each one of those minutes, there would be 60 seconds of arc. Every circle is measured the same way. But as you'll see in future slides, there are different types of circles. So every point on the Earth can be described by a combination of the latitude and the longitude of that point on the surface of the Earth. So we've got a point right here. We can describe this point by its latitude, which is 40 degrees north. Now, if we only gave it the latitude, then we could be anywhere on this 40 degree latitude line. But we also say it's at 60 degrees west, which means we're coming west 60 degrees from the prime meridian, and that gives us 1 point and only 1 point. In this particular case, 40 degrees north latitude and 60 degrees west longitude. So to get some practice for this, we're going to use the Martha's Vineyard to Block Island chart, and this is chart number 13218. For most of us, because we live in the United States, we know that this chart is from this area of the North American coast. But we should also be able to figure this out, because we should be able to look at the chart and realize that the latitude numbers are increasing as we go north, and the longitude numbers are increasing as we go west. So let's get the chart out, lay it out on a table, and we're going to be looking at the lower right-hand corner. So let's pause this video until you get the chart out and lay it on a table, and let's start looking at this lower right-hand corner. When we look at this lower right-hand corner, you can see that right here we have 41 degrees, and that's what this little symbol represents, and 5 minutes. As we go north, we can see up here we have 10 minutes. This 10 minutes would still be 41 degrees, 10 minutes. They just don't put the 41 degrees at every mark. So between this 5-minute mark and this 10-minute mark, we have 5 minutes of latitude. So by inspection, we can look at it and say, this must be minute number 6, this must be minute number 7, this must be minute number 8, and minute number 9. Same going the opposite direction. If this is 41 degrees 5 minutes, this would be 4 minutes, this would be 3 minutes, and this down here at the bottom of the chart looks like it would be 41 degrees 02.5 minutes. Now, each one of these minutes is also divided into 10 smaller increments. So each one of these smaller increments must represent 6 seconds because each minute has 60 seconds in it. We have 10 of these increments, therefore each increment must be equal to 6 seconds. And down here at the bottom of the chart, we can see we have 1, 2, 3, 4, and so the line at the bottom of the chart itself must be 5. So the latitude at the very bottom of this chart is going to be 41 degrees, 02.5 minutes. Now, taking those same concepts and applying them to the longitude, as we look down here, we can see we've got 70 degrees, 40 minutes. Over here we have 45 minutes, and here we have 50 minutes. As we keep going, when we get to 60, we should expect the number of degrees to increment to 71 degrees because each degree has 60 minutes. So here we have 70 degrees, 40 minutes, 45 minutes, 50 minutes, 55 minutes, 56, 57, 58, 59, 60, or 71 degrees. And again, if we look at an individual minute, let's take from 45 to 46. When we look in here, we can see there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 minor increments. So each one of those minor increments will represent 6 seconds of longitude. Now to use this, let's look at the lower left-hand edge of the chart. So let's go over to the left-hand edge of the chart and we'll start using our latitude and longitude. The first thing we're going to do is figure out what the latitude and longitude is of this Morris A whistle light. And I'm going to change software so I can use some different tools. Now, we've been asked to find the latitude and longitude of this red and white Morris A light. We can either use our rolling ruler or parallel rules to find these measurements, or we can use our dividers. We're going to start by finding the latitude, and you can see my rolling ruler isn't quite long enough to reach the scale on the left-hand side of the chart, so I'm going to use the dividers for this particular measurement. We're going to put one end of the dividers on the light and then stretch out the dividers so they reach the bottom of the chart. Go just a little bit further. Then we take that measurement and we transfer that measurement over to the side of the chart. So we make sure we take the dividers and we set one edge of the dividers on that same line of latitude, and then we mark what the latitude would be on this side scale. So you can see here we have 41 degrees 5 minutes. Here would be 41 degrees 6 minutes. So the latitude would be 41 degrees 6 minutes north. Now let's find out what the longitude would be. For the longitude measurement, we're going to use our parallel rules or rolling ruler. I don't have a graphic for parallel rules, so I'm going to use this and slide it around as if it was a rolling ruler. The first thing we have to do is take it and align it so that it is aligned with a line of longitude. You have to do this because you have to square up your instrument to the chart. You couldn't take the rolling rulers, have them at an angle, and say, okay, we're going to measure this longitude when they're on that kind of an angle. So the first thing you have to do is take the parallel rules or the rolling ruler and align it up with a line of longitude. You then slide it across, picking a spot through the center of the light, and then pick your measurement from this spot right here. So you can see here's 25 minutes, so this would be 24 minutes, this would be 23 minutes, so 23.1234. So our longitude is going to be 71 degrees, 23.4 minutes. So back to our original software. Here are our two lines. We can see our latitude is 41 degrees 6 minutes and our longitude is 71 degrees 23.4. Now either one of these could be described in seconds. So our latitude would be 41 degrees 06 minutes 00 seconds. Our longitude would be 71 degrees, 23 minutes, 24 seconds. In this course, we are not going to use the 24-second terminology. We will only deal with a tenth of a minute as our accuracy. The second way of using latitude and longitude is to be given a latitude and longitude and then have to find the object at that given latitude and longitude. So in this example, we've been asked to find a latitude of 41 degrees 09.2 and a longitude of 7133.1. Again, let's use latitude first, and let's use the rolling ruler to figure out what that latitude would be. So we take the rolling ruler, we align it up with a line of latitude. Now again, remember, it doesn't really matter which line of latitude. We could start out here, we could start out down here. I'm going to start out here because it happens to be closer to our 41 degrees 9 minutes. We're right now at 41 degrees 10 minutes north latitude. So this would be 41 degrees 9 minutes. This would be 41 degrees 9.1, and this would be 41 degrees 09.2 minutes. Now, by looking at this, you can probably make the assumption it's that Block Island light, but let's just make sure. We take our parallel rules, put them away. We bring our dividers, and we want to align them with a line of longitude. So we'll use the 71 degrees 30 minutes. We then want to find 33.1 minutes. Here's 30, 31, 32, 33.1 would be right there. We then bring the dividers up to the area of the chart we want to work with. We go from that same line of longitude and we measure over, and we see it is indeed the Block Island light. So in summary, you can use either your parallel rules or your dividers to figure out latitude and longitude. Here's the answer to that question. It is the Block Island light. So now we're going to get back to some definitions. What is a great circle? This is a really important concept in navigation. A great circle is the intersection of the sphere and a plane which passes through the center point of that sphere. So in other words, the equator is a great circle, because if you took a bandsaw and cut the globe through the equator, it would also go through the center of the Earth. However, none of the other lines of latitude are great circles, because if we were to take a bandsaw and cut along this line of latitude, the cut would not go through the center of the Earth. By contrast, every line of longitude is a great circle. If we were to take a bandsaw and cut through this line of longitude, it would go through the center of the Earth. As it would with this line of longitude and this one, every line of longitude is a great circle. The equator is a great circle. Absolutely every line of longitude is a great circle. But the third great circle, and the one that is most important to us, is that any 2 points on the surface of the Earth can be connected in a great circle. So if we have one point right here and we have another point down here, you can create a great circle that goes through both of these 2 points. And you can see that is what is shown on this diagram. This plane that is cutting through those 2 points is also cutting through the center of the Earth, therefore creating a great circle. So the important thing to understand here is that any 2 points on the surface of the Earth can be connected with a great circle. So this is an example of what happens with airplanes. This is San Francisco. This is Tokyo. They fly the Great Circle route there because it is the shortest route. Now, it's a little different coming back because they've got the jet stream, which is blowing at 300-400 miles per hour. So they can actually get better fuel economy and faster speeds by following the jet route home. But on the way over, they very much take the Great Circle route. And if you were on a boat and traveling at the speeds boats travel at and not having the jet stream to help us, you'd be taking the Great Circle route from both San Francisco to Tokyo and from Tokyo back to San Francisco. So again, to repeat myself, The most important point here is that any 2 points on the surface of the Earth can be connected by a great circle. We're going to start talking about the nautical mile now. And the nautical mile is a measurement of distance. So if we're going to start talking about measurements of distance, we should spend just a few seconds talking about the origins of measurements of distance. In order to standardize things, King Henry I of England standardized measurement for the foot. The meter was originally intended to be 1/10,000,000th of the distance from the Earth's equator to the North Pole at sea level. Now, it turned out not to be true, but that was the original intent. So what is a nautical mile? And we have to remember here that a nautical mile is a distance of measurement on the surface of the Earth. So the technical definition, a nautical mile is a unit of length that is 1 minute of arc of any great circle. So that's what it was originally intended to be, is 1 minute of arc on any great circle. Now, by international agreement, it has been set at 1,852 meters, or about 6,076 feet. The conversion factor between nautical miles and statute miles is 1.15, or 0.85 if you're going the other way. So if you have 10 statute miles, and you want to find out how many nautical miles you're traveling, you would multiply by 0.85. So 10 statute miles would be 8.5 nautical miles. If you had 10 nautical miles, then you'd be traveling at 11.5 statute miles. The really important concept that you have to remember here is that 1 minute of arc on any great circle is equal to a nautical mile. And it's also known as 1 minute of latitude, and we'll talk about that here in a second. So let's go back to the definition of what is a great circle. A great circle is a circle that when it goes around the surface of the Earth and you were to cut a plane through the Earth, that plane would go through the center of the Earth. So absolutely every line of longitude is a great circle. So this line of longitude going right up here is a great circle. So notice what we're measuring as we measure along that line of longitude. As we come up 15 degrees, we have the 15-degree latitude line. 30 degrees, we have the 30-degree latitude line. So as you measure along a line of longitude, you are really measuring latitude. So now let's look over here to the right, where we've got a picture of the left-hand edge of our chart. So right here, we can see that we've got 41 degrees 5 minutes, and right here we can see we've got 41 degrees 10 minutes. So between those 2 points we have 5 minutes of latitude. But this entire section of the chart is taken from an area right about in here. So this edge of the chart going up along here is the same as this edge of a line of longitude. Now, granted, it happens to be over here on the eastern coast of the States, but it's exactly the same concept. So this vertical edge of the chart is going right along a line of longitude. Here we have the 41 degrees 5 minutes, 6 minutes, 7 minutes, 8 minutes, and 9 minutes, with our final point being the 10 minutes here. So each one of these segments represents 1 minute along a great circle. Therefore, they represent 1 nautical mile. But as you can see, because we're working along the edge of the chart, it also measures 1 minute of latitude. So you will hear the expression that 1 nautical mile is equal to 1 minute of latitude, and that is totally valid. However, the more accurate way of thinking about it is that 1 minute of arc on any great circle is equal to a nautical mile. If you take your dividers and you measure this distance right here, and then take it down and measure it against the bottom of the chart, you'll see there's a significant difference. And that's because as we get further north or further south from the equator, the lines of longitude get closer and closer together until you're at the North Pole where they all meet. Therefore, as we get further north, there's going to be a difference between a minute of latitude and a minute of longitude. Because we're measuring along a great circle, as we're measuring minutes of latitude, they will always be the same distance apart, representing 1 nautical mile. So let's do an exercise. We're going to measure the distance between 2 points. Remember that any 2 points on the globe can be joined by a great circle. 1 minute of arc on any great circle is equal to 1 nautical mile. So the way we get distance measurements is we measure the distance between any 2 points and then compare it to the latitude scale on the side of the chart to get the distance between the 2 points. Now remember, when we're measuring along the latitude, we're measuring along a great circle. So again, dig out your Martha's Vineyard to Block Island chart, and we're going to be using this area on the left-hand edge of the chart, pretty much in the center of the chart. We're going to measure the distance between 2 points, Point Judith and the flashing green 1B1 bell, and those 2 points are located down here on the left-hand edge of the chart and up here at Point Judith. So pause the video until you've found those 2 points and then continue to play the video as we measure that distance. Okay, so here is our one light and here is our second light. We want to measure the distance. So the first thing that we want to do is draw a line between these 2 points, as you see I have done here. We want to take our dividers and we want to measure that full distance. But you can see my dividers don't go far enough. I could take a ruler and measure from here to here and then take the ruler and take the same measurement against the latitude scale, but that is far harder. So what we're going to do, I'm going to take my dividers and I'm going to set them at a 4-minute mark. So that means that this distance measurement represents 4 nautical miles. I then take my dividers, I put the dividers on the starting point, and I make an arc where that 4 nautical miles is represented crossing the course line. I then take my dividers, I bring them down to that point, and then I collapse the dividers so that I've got the remaining distance. You can see that is now the remaining distance. I then take that remaining distance, I bring it up to the scale on the side of the chart, and you can see I'm measuring 123.6 nautical miles. So that total distance would be the 4 original nautical miles plus the 3.6 equals 7.6 nautical miles. So in summary, measuring from Point Judith to the flashing green 1B1 bell, our distance is 7.6 nautical miles. Let's do a second. Let's go from Point Judith to the Morris A and B light. So we're now going from Point Judith to this Morris A and B light. Try pausing this video and doing it yourselves and then watching the answer after you've figured it out for yourselves. All right, we're going from Point Judith to the Morris A and B light. So we follow the same procedure. We take the dividers, and it doesn't really matter which end we have where. We put one end on the finishing point, we put the other end on the starting point, and then we take that, we bring it over to our latitude scale, and we measure 4.4 nautical miles. A lot of people have asked the question, well, how can we take a sideways measurement and compare it to a vertical scale? Shouldn't we take this sideways measurement and compare it with the scale at the bottom of the chart? And the answer is no, because any 2 points on the surface of the Earth can be connected by a great circle. This line from here to here is only one short segment of a great circle. So to find the length of that line, we have to compare it to a great circle, and this line of longitude on the side of the chart is a great circle. And again, remember, it is a line of longitude, but we're measuring latitude along that line of longitude. Just for fun, take these dividers, take that same distance, and bring it down to the bottom of the chart, and you'll see that it is significantly different. And that's because as we go further north, from the equator or further south from the equator, the lines of longitude get closer and closer and closer together. So we cannot use the bottom or the top of the chart to measure distances. We could if we were at the equator, but only when we were at the equator. And there's a great story of a person starting out from England, sailing around the world, and they were in radio communication with their base back in England. And as they started out, their navigation was really, really wacko. But it kept on getting better. This is in the days of celestial navigation. They were using a sextant, but it kept on getting better, and it kept on getting better. And they kept on thinking, well, it's just the person's getting more used to using the sextant and getting more used to doing the navigation properly. And all of a sudden, it started getting worse again. The person had just crossed the equator. They were using the wrong scale to measure distance. We always have to use the sides of the chart. So in summary, the distance from Point Judith to the Morris A&B Light is 4.4 nautical miles. And that is the end of our module on latitude, longitude, and the nautical mile. Thank you very much for your time. This is Jim Cook. Happy sailing.